I think over the last few sessions, some of my friends and colleagues have talked to you about LLMs, the large language models, the craze of today. I think by now many of you would have figured out that LLMs have become super important. In fact, I would like to say this in context. In the year 2000, where perhaps many of you were not born, we saw the first underpinnings of the internet. And in those days, I still remember a company was deemed by, in order to enhance the status of a company, we had a website for every company. So if your company was one which didn't have a website, that means it didn't have the right status. So in those days, companies used to create websites, pay a lot of money to host them, create them, and then maintain them. Now in many ways today, LLM has taken that space, especially the category of LLMs which is of importance to you and me, which is these enterprise LLMs. Going forward, I see this as an opportunity, a very big opportunity for all of us as software developers, coders, designers, all of these to create these enterprise LLMs. Now what is an enterprise LLM? An enterprise LLM is basically a large language model, but which is trained on or trained to serve data specific to your organization. A typical chat GPT will not be able to tell much about you or your organization because it has never been trained on that data, because some of that data is proprietary. Some of the web crawlers which have been used to train ChatGPT have not used that data, whatever may be the reason, and maybe ChatGPT is not interested in the data that you have on your website. So what do? Now you want to create an LLM which is seeded with your data, your enterprise data. So such an LLM is not available in common market. So you have to create, and that creates an opportunity for us, because sooner or later every organization is going to demand an LLM which is meant for itself. It is going to have its own data. So it's basically a conversational agent. An LLM is essentially a conversational agent which gives information about a particular domain, about a particular enterprise, or maybe even about a particular person. I mean, it's not too difficult to imagine that one day every person will have his own agent, and if you want to talk to the person and the person is not available or doesn't choose to be available, he can say, talk to my agent, he knows everything about me. And the agent, you can converse as you are conversing with the real life person, and it will give you information, it will also give you actionable items. So that's the way of the future. So when people say Gen AI is going to take away jobs, I think that's not entirely true, because Gen AI using LLMs is going to create a whole lot of jobs for you. And one of the key technologies for LLMs is how do you create an enterprise LLM. So let's talk a little bit about what is an enterprise LLM. I think I talked what is an enterprise LLM. I would rather elaborate on how do you create an enterprise LLM and what is these techniques used for that. So let me talk to you a little bit about what is enterprise LLM. Or rather, how do you create an enterprise LLM? You'll have to pardon my handwriting, it's not very good. So how do we go about creating enterprise LLM? First of all, what is an enterprise LLM? An LLM which is seeded with the data of an enterprise or a person or a specific domain is called an enterprise LLM. How do you create an enterprise LLM? Well, there are largely or by and large two techniques. The first technique is the first way of doing it is what we are going to see at length today is called RAG. RAG stands for retrieval augmented generation. Retrieval augmented generation. The second way of creating an LLM is fine tuning an existing LLM. So you will see, and as you spend more time with me, you will understand both these approaches, because honestly I teach both the approaches. Now which is better, which is worse, depends on the situation. Fine tuning actually changes the LLM itself, and RAG really does not change LLM, but it gives a prompt or it gives a context to the LLM. So, if your context is changing often, that is, you have an LLM, sometimes it works with one enterprise data, sometimes it works with another enterprise data, sometimes it works with a third enterprise data, then the right technique to use would be retrieval augmented generation. And why would that be? Because that will not change an LLM. If you do not want your LLM to change, to adapt itself to a particular data, you want to keep the data generally outside the LLM, then you would use retrieval augmented generation. But if your data is not changing and you know that I want to create an LLM with a bunch of static data which is not going to change often, then maybe fine tuning the LLM with this extra data which is largely static, in the sense which does not change too often, may be a good idea. So, I will just put a note here with the understanding that that is not really true. So, I will say RAG is very good when the dynamic data is there, that is, data is changing and you can't afford to change the LLM which is driving this data, whereas fine tuning means that we work with static data largely, and here the LLM itself, the large language model itself, does not change. When I say LLM does not change, what does it mean? An LLM is all about weights and parameters and all of that. So, none of the parameters change. In an RAG, it is all outside. The enterprise information is added kind of outside. It is not fundamentally changing the DNA of the LLM. Whereas here LLM does change, meaning let me put it, it does not change in the sense parameters remain same, and parameters of the LLM remain the same in case of RAG, and here LLM does change means parameters are changed. This is obviously more expensive to do, because you have to run at least couple of epochs or 2 or 3 epochs of the LLM engine all over again. You need to have access to the model and need to change it for that specific data. It requires a huge amount of GPU power, and obviously it is not always doable. This is always doable. So, well, I have kind of tried to give you a perspective that I want to create an enterprise LLM. I have an option of fine tuning an existing LLM, or I do not tune an existing LLM. I use the principle of RAG. Actually, there is a related principle of RAG which I will talk about a little later, called GAG, that is the graph augmented generation. This is retrieval augmented generation. Some people use the GAG technique, some people use the RAG technique, and that is how it works. So, today what I am going to do is I am going to talk about the RAG technique. So, this was just to give you a perspective of how to go about doing it. Now, I will give you a little more understanding and I will talk about how RAG works, so that you can go ahead and use it in some of your projects. So, we just saw what is an enterprise LLM. I think now I will just take you through a quick tour of how do you create RAG. So, what you are seeing on the screen is the flow chart of an RAG implementation using an LLM. So, I will try and walk you through each part of it. Let us see how much you understand. So, let me start. So, here we have what is called as documents. Now, what does document mean? See, every enterprise has data. Now, the data is encapsulated in documents. So, basically when I say documents here, or what they mean by documents here, is a whole bunch of data of the enterprise that is called the documents of that enterprise. Now, these data can be created using web crawlers, or this data the enterprise may already have, or the data this data may be residing in the ERP systems, or the data may be residing in some storehouse of the company. So, one of the first jobs is to get the data from these data storehouses, collect the data and create a collection of the documents which you want the LLM to use to satisfy the queries. So, when you choose the documents, you have to understand what is the kind of utility your LLM is going to provide, what are the kind of questions the LLM is going to have to answer. Depending on the questions which the LLM will have to answer, you will have to collect appropriate data, appropriate documents and bring them together. Now, what do you do with these documents? We are following the blue thing first before we go to the green. So, we take the documents and we convert it into embeddings. These are called converting the documents into embeddings. Now, this requires a little more meaning and a little more understanding. So, what happens? So, documents is essentially text. It can be pictures too, but let us limit today the discussion to text. So, documents is a whole bunch of text. Now, the word text obviously consists of words, words are expressed as sentences, sentences become paragraphs and so on. So, now what does embedding really mean? As I said, documents contain at the end of the day words. Now, all the words, as I said before, I have to step back a little. See, before we go to embedding, the documents have to be tokenized. Now, what does tokenization mean? Every word in the document has to be converted into token. Now, does each word become a token? No, sometimes, most of the time every word will become a token, but sometimes every word will not become a token. Sometimes one word will become two tokens. For example, something may become two tokens, wonderful may become two tokens. So, it depends on the way the tokenizer works, that these tokens may be words may be converted to one token or two tokens. So, prior to embedding, there is a phase called tokenizing, which probably has not been shown here. So, there is tokenizing followed with embedding. So, I have a token, or our document consists of a bunch of tokens. Tokens are just numbers which are given by the tokenizer to every word or every word or every part of a word. So, right now let us imagine words and tokens are the same. So, there is a number given to every word. So, let us say the number given to this word is 312, the number given to this word is 514 and so on. How are these numbers given? Because they are taken from some kind of a vocabulary, and this represents the key field or the index in the vocabulary. See, everything has a language, including all the documents. All the words found in a language in the document are part of a vocabulary, and the vocabulary is numbered, let us say, from 1 to n, imagining n is the total number of distinct words which we have in these documents. So, this indicates 312 is one of the words which is occurring in the vocabulary. 512 indicates the position of the second occurring word in the document. Please remember, right now I am thinking tokens and words are the same. They are not exactly the same, but at the moment let us consider them as same. So, these are the tokens. Now, these numbers do not mean anything, they are just indexes in the vocabulary. So, indexes of vocabulary. So, on their own they have no meaning, but now comes a very important step called embedding, and there has been a lot of work done in the last decade on this embedding. Let us say this word represents king, and let us say this word represents a cat as a concept. So, now the king is converted, the word king is converted into a vector. Now you will say, what the hell, what is this vector? This vector is a representation of the word king in a high dimensional vector space. So, for the sake of example, let us say my vector space has 512 width. So, imagine a vector which has 512 dimensions. Normally we think of a vector in 2 dimensions, we say x and y. Sometimes we think in 3 dimensions, x, y and z. Now imagine we are thinking of this vector in 512 dimensions. So you can imagine the gigantic vector space into which we are translating the word. So this is getting translated into a vector of 512 bit positions or positions, right. So this is one vector. Now this may be another vector, okay, which represents another 512 positions wide. Now here comes something very important. This is called embedding, that is converting a word from the token form to its vector form. This is the vector form and this was the token form. So this is called embedding. Now this is a very important step, and you will say, why do I convert a word into its vector space? What does this vector represent? The vector represents the semantics of the word king. This vector represents the semantics of the word cat. Now what does it mean? I will tell you something interesting. So if I take this vector which represents a king, okay, and I subtract the vector which represents man. Man also has a vector, right? Man is also a word, a token, and therefore it has a vector, and add woman to it, then I will get queen. I will come to the vector close to the vector of queen. Now this is very interesting. King minus man plus woman is equal to queen. Isn't that very interesting? So these vectors, all of this, these are all vector operations. So I take the vector for king, subtract the vector for man, add the vector for woman, and what I am getting at the end is the vector for queen. So these vectors have a lot of meaning. They are not just created by just mapping a word arbitrarily or randomly into the vector space. Same thing, let us say I have a vector for cat and I have a vector, let us say I have another word, let us say kitten. So this is kitten. So the kitten word or token is converted into a vector. So let us say this is the vector which represents a kitten, this is a vector which represents a kitten. Now just as an illustration, if I subtract king minus son is equal to prince, okay, and if I do that, let us say with cat minus son is equal to, I should get kitten, I should get this vector. So these vectors are not very stupid, they are extremely intelligent. Look at the way I am doing it. So what I am trying to say is, if you take away the son part of a cat, then you are left with a kitten. If you take the son part from a king, you get a prince or some kind of a relation like that. So you may not agree with this logic behind it, but the vectors work in that way. So these are very intelligent vectors, and so that is called embedding. So the documents are taken and they are embedded into an embeddings model, using an embedding model. So the embedding model is responsible for converting the documents into an embedded form. Now what do you do with that embedded form for the documents? There is a special kind of a database which is called a vector database. Because these embeddings are nothing but vectors, we need a database of sorts which we call a vector database, into which these embeddings are stored. So I need a vector database to do that. So, there are different kinds of vector databases, vector engines which are available. We during the course of further discussion, I will also introduce you to code where we will see some vector databases, how they work. So, at this stage just understand the documents are first broken into tokens. Tokens are embedded using an embedding algorithm or embedding model into vectors, and the vectors of the document are stored in a special database called vector DB. So, what does vector DB offer? It offers a search and store mechanism for vector data. So, they are customized for storing vectors and they are customized to enable searching on vectors. So, that is their job. So, that is a vector database. So, this is what happens when the documents are consumed. This is all that happens when documents are consumed. When you ask a question from the enterprise of the enterprise LLM, then that is called a query, and then we will go through this journey and understand the green part of this diagram to illustrate what happens when I give a query, when I ask a question to this RAG LLM that I have shown here. So, during the creation or the absorption of the documents, only thing that is done is the documents are tokenized, then the tokens are converted into an embedded form, and the embedded form is converted into a vector database, is stored in a vector database, and the vector database is capable of storing or searching. Isn't that very simple? Very simple to make it happen. So, and if you can write some code which can make it happen, you are writing some useful stuff, which is you are trying to make an LLM or trying to enrich an LLM, I would say. Okay. So, let us continue with how what happens when there is a query. Okay. So, let us continue with our journey when we have the query. Okay. So, let us see what happens. So, when I ask the document, when I ask the LLM for something, that is called a query. That is, I am looking for some information about the enterprise. So, that looking for information, which I speak in English, is called a query. Now, what happens with the query? Just like my original data was converted into an embedded form, the query also has to be understood and converted into an embedded form, because my query is also what is the revenue of this enterprise, or what was the sales targets of the last quarter for a particular product. If I am asking this kind of questions, basically my question consists of text, and that text has to be converted into tokens, and the tokens have to be converted into their embedded form. So, the query also goes through the same embedding model, and what happens to the query now? It has been converted into its embedded form. So, I have a bunch of search vectors. Let us call these as search vectors. These are the vectors I am looking for, because that is part of my query. So, next what happens? My document has already been stored in vector form in the vector database. All the vectors corresponding to my data, corresponding to the words in my original document, have been captured and put in the vector database already. Now, I am getting a query. My query has been tokenized, tokens have been converted into their embedded form, and now what is happening? This embedded form of my question is called the search vector. I am looking for it. So, the vector database, just like an SQL engine, once it is given this search vector, responds in the vector database by identifying the documents from the original set which might be similar to the query. It says that what you are looking for perhaps will come from these documents. This may not be a complete document, this may be chunks of documents, pieces of documents, because normally we do chunking, breaking up the document into smaller parts. So, those smaller parts are tagged in the vector database originally, and so they are identified as part of the search, that perhaps the words that you are looking for or the answer that you are looking for may be found in these documents. So, these documents may be of interest to you, So that documents along with the query. So it has identified, I would say, instead of documents, I would say chunks of information has been identified by the vector database that this might help you. So that chunk of information along with the original query forms the prompt for the actual LLM. See, so far we have not reached the LLM. Now we will go to the LLM. What will we go to the LLM with? We will go to the LLM with a prompt which essentially contains the original query and the possible chunks of data or information from which the query can be answered as per the vector database. Now what the LLM has to do? LLM understands the English of it, LLM understands the context of it, LLM understands how to understand what has been asked and how to generate a response. So this is an LLM. Now this LLM can be any LLM. It has not been fine tuned, so you can just pick up an LLM. Another advantage of this approach is most of the process up to here is same, it is not dependent on the actual LLM that you are using. So here if you are not getting good results with a particular LLM, you could swap it out and get another LLM, which probably if you can afford you can use it. So we are not tied to any LLM. So far whatever we have done is outside the LLM. So now the query and its associated documents which were coming from the vector database have been taken and they will be sent to the LLM, and LLM understands its job now. It is a master of responding to prompts. So it looks at the query, looks at the documents where this query probably has its answers and generates a proper response which is specific to the enterprise, specific to the question which has been asked, and this is the process in which RAG works. So this is the overall process of working with an RAG. Now I have given you a rough cut idea of how prompts are created and how an RAG works. There is a lot more to it obviously, and we will talk about that in subsequent sessions. Okay, thank you.